In this video, we're solving a second-order differential equation using the method of undetermined coefficients. For this example, we're solving y prime prime minus 5y prime plus 6y is equal to 52 cos 2x, with the initial conditions y of 0 equals 0 and y prime of 0 equals 1. Since we have a non-homogeneous equation, we need to start by solving the corresponding homogeneous equation. Replacing that right-hand side with 0, we get the homogeneous differential equation y prime prime minus 5y prime plus 6y equals 0. We start by assuming that we have an exponential solution y equals to the kx. So differentiating this and substituting it into our second-order differential equation, we get the quadratic equation k squared minus 5k plus 6 is equal to 0. In this case, we can factorize k minus 2 times k minus 3 is equal to 0. Therefore, k is equal to 2 or k is equal to 3. So using the table, we can see that we've got two distinct real roots. Therefore, the complementary function is y equals a e to the 2x plus b e to the 3x. The next step is that we need to find the particular integral that will give us that function on the right-hand side of our original differential equation. So we need to find a function which is of the same form as that right-hand side. So since we have cos of 2x, we assume that the particular integral is c sine of 2x plus d cos 2x. So from here we can differentiate the particular integral. We get 2c cos 2x minus 2d sine 2x. And differentiating again, we get minus 4c sine 2x minus 4d cos 2x. And we substitute these into the original differential equation. When we simplify, we end up with 2c plus 10d of sine 2x plus minus 10c plus 2d times cos 2x. And this has to be equal to 52 cos 2x. So comparing the coefficients, so the coefficient of sine on the left-hand side has to be equal to the coefficient of sine on the right-hand side. So on the left we have 2c plus 10d, and on the right-hand side we have 0 sine. Therefore 2c plus 10d is equal to 0. Comparing the coefficients of the cos 2x, this gives us that minus 10c plus 2d is equal to 52. So we've now got a pair of simultaneous equations that we can solve to find the values of c and d. You can solve these using any method that you know. Here I'm going to use elimination. So first of all, I want to eliminate the d's. Taking that first equation, 2c plus 10d equals 0. So to eliminate the d's, I need to get minus 10d in that second equation. It currently has 2, so I'm going to multiply that second equation by minus 5. And this will give me 50c minus 10d equals minus 260. I can now add these two equations together. So 2c plus 50c is 52c. And the 10d minus 10d will be 0. And the 0 minus 260 is minus 260. So solving 52c equals minus 260 will give us that c is minus 5. Now we want to eliminate the c's so that we can find the value for d. So that second equation has minus 10c, so I want to make the first equation have 10c as well. So multiplying the first equation by 5, this will give me 10c plus 50d equals 0. And then leaving that second equation as it is, we're going to add these two equations together. So 10c minus 10c is 0. 50d plus 2d is 52d. And then the 0 plus 52 is 52. So dividing by 52, we can see that d is equal to 1. So now substituting in the values for c and d into our form for the particular integral, we get that the particular integral ypi is equal to minus 5 sine 2x plus cos 2x. So our general solution is going to be the complementary function plus the particular integral. So y is equal to a e to the 2x plus b e to the 3x plus the minus 5 sine 2x plus cos 2x. And we can now use our first initial condition. So substituting x is equal to 0 and y is equal to 0, we get that y equals a e to the 0 plus b e to the 0 plus minus 5 sine of 0 plus cos of 0. So the cos of 0 will give us 1, the sine will vanish, the e to the 0 is 1, so this will simplify down to a plus b equals minus 1. So this gives us an equation that we can use with the next equation that we're going to get. Taking the second initial condition, we need to differentiate y. So this will give us y prime equals 2a e to the 2x plus 3b e to the 3x plus minus 10 cos 2x minus 2 sine 2x. So substituting x equals to 0 and y is equal to 1. This will give us that 1 equals 2a e to the 0 plus 3b e to the 0 minus 10 cos of 0 minus 2 sine of 0. Again, the sine of 0 will vanish. The cos of 0 is 1, which will leave us with the minus 10. The e to the 0 is 1, so this will all simplify down to 2a plus 3b equals 11. So we've got a pair of simultaneous equations we can solve to find a and b. You can solve these using any method that you know. Here I'm going to use elimination again. So I'm going to start by eliminating the b's. That second equation has 3b, so I want to make the first equation have a coefficient of minus 3 for the b. So multiplying that first equation by minus 3, I get minus 3a minus 3b equals 3, and then leaving that second equation as it is. We're going to add the two equations together. So minus 3a plus 2a is equal to minus a, minus 3b plus 3b is 0, and then the 3 plus 11 is 14. So a will be minus 14. Now eliminating the a's, so that second equation has 2a, so I want to make the first equation have minus 2a. So to do this, I'm going to multiply that first equation by minus 2. This gives me minus 2a minus 2b equals 2. And then leaving that second equation as it is. Adding the two equations together, minus 2a plus 2a is 0, minus 2b plus 3b is b, and then 2 plus 11 is 13. Therefore, b is equal to 13. So we can put this back into our general solution. This gives us the particular solution y equals to minus 14 e to the 2x plus 13 e to the 3x minus 5 sine 2x plus cos 2x.